President Grímsson, ladies and gentlemen, a very good morning. My name is Kristín Ingólfsdóttir. I'm rector of the University of Iceland, and it's my pleasure to chair this session on Arctic ice, global climate, and scientific cooperation. And let me emphasize a very warm welcome to you here this morning, despite the chilly conditions outside. Without further ado, allow me to introduce our keynote speaker. Cristiana Figueres has been Executive Secretary of the UN Framework Convention on Climate Change since 2010. Originally from Costa Rica, she has long been involved with energy and climate change issues. She was Director of Renewable Energy in the Americas, and in 1995 she founded the non-profit Center for Sustainable Development of the Americas, and she directed the center for 8 years. She designed and helped to establish national climate change programs throughout Latin America and served as high-level advisor to both government and private companies. In 2001, Cristiana received the Hero for the Planet Award from the National Geographic magazine. Cristiana, please take the floor.
Thank you very much, and good morning to all of you. I am taken by the fact that we meet here this morning one day after the IPCC has finally, after a lot of work, been able to agree on the synthesis report that they will be releasing for the 5th assessment report. You know, over the 2 decades that the IPCC has been serving humanity, they have actually been publishing increasingly accurate risk assessments that are helping governments and all other stakeholders understand the impacts of climate change and understand the urgency of acting on climate change. And in fact, every single IPCC report has actually been increasing in its assessment of the risks. And every time, now for the 5th time, we have increasingly sobering reports on the impacts of lives, livelihoods, and the health of our population and our planet. Today, with this synthesis report that is being released, we frankly have absolutely no doubt that we human beings have caused climate change. We also have no doubt that we must address climate change, given the impacts that we're seeing everywhere, in particular here in the Arctic. Now, all of you are here because you are convinced that we must act on climate change, so I don't need to convince you about that. You will take some encouragement from knowing that you were joined just a few weeks ago by 400,000 people who came to the streets of New York, and yes, New York is in the United States, came to the streets of New York to also be very, very clear about the fact that we must act on climate change. And they were joined by thousands of other people in 130 countries in similar events. So it is very clear, I think, that humanity has decided that we must act on climate change. Then the question is, can we address climate change? Well, that is perhaps not so clear. But I'm here to tell you that we actually do have the technology and the financing that is necessary to act on climate change. And just a few little examples will suffice. So I've been privileged enough in the scarce 24 hours that I've been here in Iceland to already go to one of the geothermal plants here. In the context of a country that in 1940 was 80% coal and oil, and that is now 80% geothermal and hydro. At this particular geothermal plant, they're also doing very, very interesting research, completely cutting-edge research on carbon capture and storage that is actually answering a lot of the safety issues on capture and storage of carbon. So yes, that is one answer. We also know that wind is growing everywhere, that we will have 2,000 gigawatts of wind in more or less by 2030, which means approximately 15% of global electricity will be produced by wind. Solar is exploding, has come down in cost 80% since 2008, and is exploding in particular in China, where they are currently building one solar power plant of 1,000 megawatts, the equivalent of a nuclear reactor. We do have the technology, and we actually have the finance to address climate change. In fact, at the Secretary General's summit in New York just a few weeks ago, that summit mobilized approximately $200 billion of commitments of investment from private sources. But is that enough? Will that actually answer the question, will we effectively address climate change? And I think that is the question that brings us here together. Because there is one compelling fact. Over the next 15 years, according to the new climate economy report just released in New York, over the next 15 years, the world together will be investing $90 trillion into infrastructure over the next 15 years, in part because the energy infrastructure is old and needs to be renewed, in part in answer to the 2 billion people who will be joining us on this planet very soon. Those 90 trillion, the funding for which is already sitting under pillows and mattresses, will have to be decided. Is that going to go into business as usual infrastructure, i.e. the technologies of last century, and non-resilient, dangerous, high-risk infrastructure, like roads and transportation? Or is it actually going to go into clean technologies and into resilient infrastructure? And if we're able to make that switch, the different cost of which is only 4 to 5%, if we're able to make that switch over the next 15 years, my friends, then we will have addressed at least the worst impacts on climate change. So the Paris Agreement, for which many of us are working, is actually the turning point that we must create for that investment to go into the clean scenario that I have spoken about. And that is exactly where the Arctic Circle comes in. You may think, okay, those crazy guys over there, they've been talking for years and years and years, and they're working toward a Paris Agreement, but here we in the Arctic Circle actually do have the answers. Well, my friends, the point is that we need your answers. We need your efforts. And why is that so? Because here the Arctic Circle, in only its second year, is already creating a platform for collaboration on solutions that actually has 3 of the fundamental characteristics that are needed by the Paris Agreement. The first is that the Arctic Circle is searching for the balance between local needs, national interests, and global responsibility, a very important characteristic of the Paris Agreement. The second is because the Arctic Circle and the Arctic Council, of course, are endeavoring to calibrate perceived short-term benefits with the long-term impacts of climate change that will affect the same beneficiaries of the short-term benefits, plus millions, if not billions, of other people around the world. And the third, because here in the Arctic, we are realizing that there is no country that is immune, that there is no one single country that can solve this problem, and that therefore our most urgent need here is to build a collaboration platform such that we ensure that no one country is left behind, that no one community is left behind, that no one family is left behind. If we are to have a solution to climate change, we must bring everyone with us for that solution. So those 3 characteristics are the same characteristics that the Paris Agreement is searching for. Governments are actually on track with respect to the timeline to this Paris Agreement. So we are working on a draft agreement that will be on every desk of every government in Lima at the end of this year, in December. In May of next year, that agreement, which will then have been further worked on, will be translated into all 6 languages of the United Nations and sent to all 194 capitals for discussion at cabinet level, because this is an agreement that cannot be put forward by one ministry. This is an agreement that has such deep implications and such deep opportunities for all sectors of human endeavor that it must receive a very careful consideration at cabinet level in every single country. And then, once that consideration has been put in place, then the governments will again be gathered in Paris in December of next year to adopt that agreement. So governments are on track for the timeline which they have set themselves to agree to the Paris Global Agreement. Are they on track with science? No. They are not on track with what is required by science, partly because they are still searching for those 3 balances that are actually being searched for here in the Arctic by the Arctic Circle and certainly by the Arctic Council. So, my friends, there is no doubt that the Arctic is the nerve center of climate change impacts, but I am convinced that the Arctic can also be the solution center for climate change. So let us work together to ensure that the kinds of issues, the kinds of collaborative platforms that you're building here, you can also take to inspire and inform a Paris Agreement that must bring resolution to the climate challenge. And how are we going to know whether that is actually the case? We will know that if the Paris Agreement is actually the turning point that takes us to global peaking of emissions over the next 10 years and then to climate neutrality in the second half of the century. If we are able to chart that path, if we're able to mark the milestones of that course toward climate neutrality in the second half of the century, which is what the IPCC requires of humanity, then we will know that we have stood up to our responsibility. I'm frequently asked by journalists, what keeps you up at night? Well, the fact is many things keep me up at night, but one in particular. I have this recurring vision of 7 pairs of eyes in front of me belonging to 7 generations ahead of us. And they all ask me, you knew, and what did you do? My friends, I'm not the only one that is going to be asked that question. Every single one of us alive today is facing that same question. So my invitation and my trust is that we are all working together to be able to answer that question in the way that we want to. We knew, and we did. Thank you.
Thank you very much, Christiana. Hopefully we will have time for questions at the end of the session. We will now proceed, and I'm afraid I'll have to be a very strict guardian of time due to the tight schedule, and I'd like to kindly ask the speakers to keep their eye on the timer here in the podium. Next, I'd like to introduce Fran Ulmer. She is chair of the U.S. Arctic Research Commission and special advisor to the U.S. State Department on Arctic Science and Policy. Fran, please.
Good morning, everyone. It's a pleasure for me to be with you today. I am going to address the topic of cooperation for international Arctic science. But before I do that, I would like to provide a little context, a little bit of U.S. and Alaska context to put into perspective some of the work that is being done. I think all of us are very familiar with the wide range of topics in addition to ice and climate change that are all interrelating, including the rapid rate of change of our cultures, our societies, our economies, that are in many ways complicated by the rate of change that we are experiencing in Arctic areas. And of course, you have seen these slides many times this week about how rapid the change is, but I just want to take one moment to remind us, because I think sometimes we become a little numb when we look at these pictures. When we're talking about 50% less extent of sea ice and 75% less volume of sea ice since the 1970s, this is not a slight sea change. This is a monumental alteration in the cryosphere and in all of the systems, all of the ice-dependent systems, natural and man-made, that exist in the Arctic. Needless to say, the way in which we can address some of these issues is through research. And I might just note that in the United States, there are a wide variety of entities that are engaged in research that help to at least understand and, to the extent possible, address the rapid rate of change that our economies and our cultures and our societies and our natural systems are experiencing. I remember being at the end of the IPY years in Montreal and seeing the phrase that was sort of the banner headline of that meeting, "From knowledge to action," which I think brings us to the point of the research needs of the world, and particularly in the Arctic region. So let's go back to the Arctic region for just a second from the US perspective. Back in the 1980s, Congress passed the Arctic Research Policy Act to bring some coordination of research policy as it relates to the Arctic into center focus. Again, that was back in the 1980s. What Congress did was identify the area that we think of, at least for purposes of this act, as the Arctic. And as you can see, it's a very broad definition, including, at least in our country, the area of the Bering Sea because of the interaction between the Bering Sea and the Chukchi and the Beaufort. That act also created the Alaska Research Commission, which I chair, as well as an interagency group among the federal agencies that really focus the investment of Arctic research dollars that are focused on the Arctic. So I would just say that even back in the 1980s, it was recognized that the investment that is being made by many different departments in our government really needed to be focused in a way that made as much wise investment of that research dollar as possible. And I'm happy to say that one of my fellow commissioners, Edward Itte, is with me today, the former mayor of the North Slope Borough and the former chairman of my commission, Meade Treadwell, who's now lieutenant governor, and many Alaskans. And that's because, of course, the US is an Arctic nation because of Alaska. Alaska is a state that is huge, 2.5 times the size of Texas, 1/5 the size of the lower 48, and yet only 750,000 people. And those of us who are lucky enough to live in Alaska have been attempting for many years to increase the attention of our fellow Americans on the challenges that Alaska faces, similar to the challenges that many Arctic people, the 4 million people who live across the Arctic, face. And in that process, I'm happy to say that progress has been made. In the last few years, the Obama administration has adopted a national Arctic strategy, an implementation plan to make that strategy real. Many of our departments have their own strategies consistent with that national vision. We have seen the Interagency Arctic Policy Working Group come up with a 5-year plan for how Arctic research dollars will be spent. And as we approach the chair of the Arctic Council next spring, many of the issues that we are addressing through our chairmanship are consistent with that national Arctic strategy. I might just note that the Arctic Research Commission, which I chair, has a number of focused responsibilities that will support and hopefully help the effort that will be undertaken for the next 2 years. And if you want to get sort of a vision of the issues that we consider particularly important for Arctic research to address, I would suggest that you pick up a copy of our goals report or go to arctic.gov, which is an important way for you to not only get access to the work that we have done, but also stay in touch with what is happening in the Arctic. And I say that that's particularly important as we try to pay attention every single day to what is happening across the Arctic. If you sign up for the daily update, you will get in your email in basket, which I know is already very big, but this is going to be very useful, a daily snapshot of what is going on in the Arctic. From the standpoint of policy pronouncements, recent research, changes in what is happening both from the natural systems but also the government level, it will be a way that will provide you some additional insight into what's going on in the Arctic. So a few more minutes. I want to draw your attention to the Arctic Council particularly as a very useful entity over the last almost 20 years of bringing together the Arctic science community. If you're really looking for a mechanism to provide the kind of coordination of both the science and the policy in the Arctic, there really isn't a better example. And as we move forward and strengthen the Arctic Council and invest in the programs that are really focused on in the Arctic Council, I would say that this continues to be an important way of providing the kind of continuity of information, but also the areas of emphasis that are most important to the people who actually live in the Arctic. There are countless of examples of reports that have been produced over the years on everything from climate change to human health that you can find by simply tapping in to the Arctic Council website. And although I wasn't asked to do this, I do want to have this be a commercial for the Arctic Council website as a resource for research that really reflects a broad range of opinions, expertise, and international perspectives when it comes to international research cooperation. The Arctic Biodiversity Assessment, the Arctic Ocean Review, Arctic Social Indicators, Circumpolar Health Systems Review, the behavior of oil and other hazardous substances spilled in Arctic waters. I could go on and on. My only point here is, when it comes to looking for a vehicle for important coordination, this is an excellent one. Let me close by simply posing a few what I consider to be incredibly important questions as we try to take Arctic science coordination to another level. How can we synthesize what the observing networks and what all of the data that is accumulated through our various individual national efforts be better placed in a transparent and accessible way for people, whether they are in the public sector or in the private sector? I think we still have room for improvement. And most importantly, I will finish with this one. The communication of the information that is generated through our various science efforts still is invisible to many people who actually need that information and need the understanding that comes from what it is that good international coordinated science can provide us. Those are challenges that all of us need to take home with us. Thank you very much.
Thank you very much, Fran. Very interesting presentation. I'd like to introduce next Jane Francis. She's Director of the British Antarctic Survey. Jane, please.
Thank you very much. You can see the title is Scientific Cooperation, so that's what I'd like to focus on. And I think there are many of you in the audience here that can help scientists to actually work together a little bit more. And I think we've heard over the last couple of days that the really important thing about the Arctic is there's lots of changes going on. It's been enforced by what's going on outside on the whole, but the Arctic itself is being affected in many, many different ways: currents, ocean currents, atmosphere, weather. And the word that's been used a lot to describe the Arctic is about the complexity of the environmental system and and the human system added to that and how we deal with it. Well, let's have a look at what actually we can do about it physically. One point I think I'd like to say is that one thing that scientists really need to understand is what is happening underneath the sea ice in the Arctic. We've heard that it's shrinking, but we don't really know what's happening underneath because for many years there has been a cover of sea ice and we haven't really been able to get underneath it and have a look. And underneath it now there are becoming some glimpses of some really interesting ecosystems, here we go, underneath the Arctic ice. And I think we really need to sort of focus on that. There's a big knowledge gap at the moment. And imagine what happens when some of those ships go across that are going through the shipping route. And one thing, they're full of ballast. They're full of water that's full of bacteria and small bugs that they're bringing from different parts of the global ocean that potentially can be released into the Arctic Ocean and will interact with some of these biota that we really don't know anything about. So I think understanding what's underneath the ice sheet is really quite critical, a critical science problem in the future. And to work on that kind of thing requires really logistically challenging practical approaches to getting scientists into the Arctic and getting them able to look under the ice. That requires a huge amount of international cooperation. And I think you'll find that certainly on the oceans, there are large ships, scientific ships working on the oceans that have got big multinational crews on, multidisciplinary crews, very expensive cruises, doing quite complex work in those areas. But on land as well, on the tundra, you can go up there and work on the tundra with a tent and just a couple of people. But again, it takes huge logistics just to get into some of those tundra areas. It requires a lot of organisation. I think also the Arctic is a good place where we can pool expertise, scientific expertise, to approach some of that complexity. And here's just an example of a group I worked with a few years ago. There's just 18 people there on Svalbard, but there were 6 nationalities in that group. We each had expertise in a different discipline, and pooling that together made a huge difference in trying to understand what we were looking at, which happened to be rocks at that time, working together. And really interestingly as well, in that group, there were half the people there were graduate students, early career researchers, who were learning to be polar scientists of the future, which I think is really important. The Arctic is a fantastic training ground for environmental scientists to take on the challenge of climate change in the future. So scientists like to work together. I think they disregard politics, which I use in the broadest sense. They hate bureaucracy. They just want to get on and do science. And I think one of the things we need to do is make sure that scientists can go out in the field and collect that precious data that we need to have to understand how the climate is changing. And that means across all regions. There are some big areas. If you heard my talk on Friday, I showed a diagram that showed there are big data gaps in what we know about the Arctic. There are people who have been in the field and worked on specific areas and got data from specific areas, but there's an awful lot of the Arctic that hasn't been touched by science. We also need to do long-term monitoring. A lot of science, I think, in the Arctic at the moment are short-term projects that you can get on grants, 2, 3 years, 5 years. Even longer ones from IPY projects. But what's the legacy of IPY? We really need, I think, to commit to longer-term monitoring, so we really need to know what's happening on a longer scale, not just these short-term variations which we've seen, but what is the real trend in the Arctic over the longer time. And I think seasonal data are also something that we're a bit short of. An awful lot of people go to the Arctic in the summer, and it's a hard place to work, but the summer is a much nicer place to be. But here, this is a picture of the Coast Guard ship, the Canadian Coast Guard ship, the Amazon, which was frozen into the Arctic Ocean in the Beaufort Sea in the IPY year a few years ago. And they had a big project called ArcticNet, which was looking at the Arctic Ocean and the Arctic environment throughout the whole year. And that seasonality is really extreme in the Arctic, much more extreme than anywhere else on the globe except the Antarctic. And I think understanding how things change is really important, not only for the changing environment and the weather and understanding climate, but also if we're going to take human beings into the Arctic more, if we're going to take shipping and industry in the Arctic, understanding that seasonal impact is really important. The Arctic is also a fantastic place, well, both polar regions. There's a lot of discussion now about new innovative technologies. And there's all sorts of things that can help us work in the Arctic without having to go up there and do risky things in difficult places. And this is a picture of a ship from the National Oceanography Centre in Southampton. And you can see their array of autonomous vehicles. And that's just a selection of a few that are available now. But we can send these vehicles out into the oceans. They can take measurements by themselves. They can stay there for years until their batteries run out and collect important data. It will be really interesting also to bring people into the Arctic Forum that are not people who are working in the Arctic at present, but who are designers, engineers, innovators who work in completely different fields on Earth and that can come to the Arctic and work with us to really think about different ways of doing science. And not different ways of doing the same science, but actually new science that we'd never thought about. And as I mentioned the other day, I think working in cooperation with industry is actually an ideal place in the Arctic. And I think scientists can help. The climate is changing, the environment is changing, and as industry comes in, they will change it as well. Two rapid changes on top of one another is not particularly a good state to be in. So let's work together to understand how the changes are happening. And something that preoccupies me a lot as head of the British Antarctic Survey is budget, and particularly the fuel budget for going to these places. Ships, boats, planes, they all take a large amount of fuel, which costs an awful lot, or at the moment the fuel price is a bit lower. And the cost of these expeditions is enormous to get to the Arctic. International cooperation really is the way to go, to share facilities, to share ship costs, to share journeys, and to share scientific projects. One of the problems at the moment is that if you apply for money to work, to do a big international project, you tend to have to apply to your national grant funder to get grants. And so you can form a really nice international group, and then they all split up and have to apply for funding in their same national pots. And we get into what we call double jeopardy, that one nation receives a grant and gets positive reviews and the other nation fails. And you start having to go through this process so many times that eventually many people give up. It would be fantastic if there was some way that we could change the funding systems internationally so that we could work together more and would get rid of this double jeopardy situation. The EU is a really good funding system. People can do multidisciplinary science across many nations. And actually, the Office of Naval Research, there are some really great projects funded by them that bring scientists together across nations. And there's some really exciting science to be done in the Arctic. And I finish with this slide because nobody's talked about the past in the Arctic. And these are some students who've worked on Svalbard. They're geology students, and they're looking for fossil leaves in the Arctic to show that the Arctic actually, 45 million years ago, was much warmer. There were forests in the Arctic, and the leaves from those forests are preserved in the rock. So you can see a long history of Arctic. It changed in the past, and it's changing again now, but much faster than it ever did in the past, and it's affecting the way we live in that region and on the whole globe. So I think scientists can work together much more efficiently and work together to answer some really big global problems in this region. Thank you.
Thank you very much. Thank you very much, Jane. It's really nice to see pictures of young, enthusiastic researchers on your slides. Going now from the UK to Norway, I'd like to introduce Jan Gunnar Winther. He is director of the Norwegian Polar Institute.
Thank you, Chair. President Grimson, distinguished audience. It's a pleasure to be here and share some thoughts with you. I will spend my few minutes pointing in 4 directions. There will be more where the science should go in the future, but I will lift out 4 potentially avenues for further work. I'll start with showing the logo of IPY. It's 7 years ago that we had a very successful initiative called International Polar Year that most of us know very well. It was a fundamental principle in IPY that project should be truly international. It was impossible by one nation alone to make that effort. That was important for IPY. It's still important because the questions we have ahead in the Arctic, they need collaboration among many nations to solve. So bold questions that we really are up front of, they require collaborative answers. I'm not advocating a new IPY. However, I'm advocating to keep some of the spirit in IPY and also some of the structure in IPY into future Arctic research. I think there is still potential, even though there is lots of international efforts going on, there is still potential to raise that somewhat. And structural-wise, I think the biggest challenge is the funding agencies. They succeedingly, excuse me, they with success managed during IPY to have multinational funding. And this is today a challenge, and I would address the funding agency to be especially aware of that issue. My second avenue is the two-way communication between the Arctic and what we often call the rest of the world, which is quite important, by the way. We know that the Arctic is affected the most by climate change. That is from the rest of the world to the Arctic. We also know that the Arctic change is influencing the rest of the world. However, this is a new study area. It's early days, and we still don't have full understanding of how this interplay between the lower latitudes and the high latitudes are. And also built into that, the interplay between climate, the long-term changes, and weather. And during a breakout session earlier at this conference, I showed this figure, which is in a way describing the old Arctic, where we had a closed Arctic and the cold air in the Arctic due to the circumarctic atmospheric circulation was protecting the rest of the world from the Arctic. Due to weaker temperature differences, we don't have that situation anymore. We have a more diffuse circumarctic circulation pattern, which actually can give us weather events that are going in the cooling direction. We need, and the world needs, to understand how this coupling is. So this two-way communication is of major importance for Arctic scientists to address. My third point is that we have I would say, dramatic lack of data from the winter, knowledge about the winter. We have had a very strong program from the Soviet Union with drifting ice stations, starting already in the 30s and then later by Russia. That has been the continuity for all-round data collection in the Arctic Ocean. We had Shiba, we had also during IPY some efforts, but we still today don't have a continuous data collection and a comprehensive one from the Arctic Ocean. And the drifting ice station program from Russia has been interrupted for a while due to the situation with the ice. Now I heard and learned that this will be continued again, and I'm very glad to hear that. I will also just inform that the Norwegian Polar Institute will freeze in its research vessel Lanse in January of 2015 and make a drift for half a year to be part of this data collection from the winter that I think the scientific community really needs. One idea that I wanted to launch is if we in the future, because of the thin ice and the weak ice, maybe not are able to use ice floes as platforms for winter observations, need to switch to using vessel. And why not establishing an international initiative with a vessel or several vessels in the Arctic Ocean all year round, and make that a truly international effort. The last point, my number 4, is that the rapidity of change that happens today we have nothing like it to compare with, and it really challenges us as scientific community and also climate modelers. What will be, to use a military term, the end state? We don't know really. And this is something the world will ask us repeatedly in the coming years. what will the end of this look like? IPCC, with its projections for the sea ice situation, the sea ice coverage, as shown here, at the end of this century, gives us some scenarios dependent on the emissions. But we need to improve our skills and our models to be better off to projecting the future. This goes also for sea level. Here again, a figure from IPCC. There is a range now of scenarios and projections for what will future bring. And the Arctic scientific community has a special responsibility, I think, on behalf of the whole world, to address these issues and to solve some of the uncertainty that we still have. And then it goes also, of course, for the ecosystem and the biological system, not only for the physical one. This is a 10-year-old figure from ICIA. However, what's happening in the ocean and with the ecosystem is under dramatic change these days, and we really don't know how it will look in the future. If you turn on the temperature with 2 degrees C and stabilizes there, we don't know what the end state is, and this is something we should pay especially attention to. Thank you for your attention.
Thank you very much, Jan Gunnar. Back to the UK, I'd like to introduce Peter Wadhams. He's Professor of Ocean Physics at the Department of Applied Mathematics and Theoretical Physics at the University of Cambridge. Peter, please.
Thank you very much. The issue which I would like to address is the current rapid retreat of sea ice and what some of the implications of that are for climate and for the future of our planet. And here we are. We've all seen this picture. It's been shown several times, I think, during this meeting, and it shows the most extreme summer retreat that's occurred so far in 2012, and we see the difference between that and the black line, which is the way the summer sea ice used to be. Now, to get a feel for that, those of you who go up regularly up to the Arctic will have been aware of how rapidly conditions have changed. And so I'll show a then and now picture. And this was the first one here was 1970, August of 1970, my first summer in the Arctic. And this is the Canadian ship Hudson. This is just north of Prudhoe Bay. In fact, it's trying to get round past Prudhoe Bay, and we see it's trying to handle very heavy multi-year ice flows, really thick and quite challenging to even to an ice-strengthened ship. Now, this shows this August on the US icebreaker Healy, and about 400 miles north of Prudhoe Bay, and the ice that it's in is very, very weak, vulnerable, and you only really have to sneeze at it and it will melt because it's really extremely thin and weak, and we can see that it was on the verge of melting. The ice that remains in the summer now in the Arctic is first-year ice, and it's extremely thin and weak ice. So how do we know all this? Well, we have been going under the ice for quite a long time, and the measurements of ice thickness in the Arctic and the ice thickness distribution really started in 1958 when the Nautilus, the US submarine, went to the Arctic and got upward-looking sonar data along its track. And the British programme, which I think could be described as a sort of distinctive British contribution to Arctic science, started in 1971 with the very fine glaciologist Charles Swithinbank going on a British submarine, and many of you will know him. He died very recently. And then I took over the programme in 1976, and it continues, and with voyages at longer intervals than the US submarines, but US results and British results are put together. We now have multi-beam sonar, which gives us this very beautiful views of the underside of sea ice and what it looks like. Putting the US and the British data together and looking at the submarine, at satellite data, we now have this very frightening, rather frightening but impressive picture of how the volume of sea ice is decreasing. This is the volume in the minimum period time, which is mid-September, and the volume, this is real data, and it's obtained by multiplying the area of the ice, which is measured very accurately from satellites and has been for many, many decades, multiplying that by the thickness, mean thickness, which is inferred from all the US and British submarine data interpolated. So when that is put together, we get this curve, which again is based purely on the data, no model here, this isn't data, and it's showing a decrease in summer which is quite precipitate, it's accelerating downwards, and there doesn't seem to be, although there was a slight recovery this year, there doesn't seem to be anything to stop it from going down to zero. So we can expect summer sea ice to disappear very soon, and this is much sooner than is envisaged in many models, which show that the models are not taking account of data, and also sooner than envisaged by the current IPCC assessment, possibly within the next 2, 3, 4 years. By 2020, we would expect the summer sea ice to have disappeared. And summer means September, but the other months follow on behind, and this is a representation of what the data show for the area or the volume of sea ice in different months of the year. So it's been called the Arctic death spiral by Marc Serres in Boulder, because it's showing the volume spiraling in towards the center line. And it means that not only will the September sea ice disappear, but not many years afterwards, the neighbouring months will also become ice-free. That's July, August, and October. It will take much longer for the winter sea ice to vanish, of course, but it's shrinking. What does that mean? Firstly, there's a reduction in the global albedo when the sea ice disappears, and this is an estimate that's in a paper that was published by colleagues at Scripps earlier this year, which is that the reduction in albedo caused by this opening up of the Arctic is equivalent to adding about a quarter to the greenhouse gas emissions. The heating effect of that is like increasing our emissions by a quarter. A second feedback is the snowline retreat. And the retreat there is very great in spring and early midsummer when the insolation is very high. And in fact, we find that the anomaly of snowline area in the Northern Hemisphere has reached 6 million square kilometres, which is as great or greater than the reduction in sea ice area. And of course, you remove snow, it's having the same effect on albedo as removing ice. The second thing which many people have gone into at this meeting has been the fact that the warmer air masses over the Arctic cause faster melting of the Greenland ice sheet, and that's causing the Greenland ice sheet to lose mass at an accelerating rate. And that means that our predictions about sea level rise this century are being constantly revised upwards. The IPCC fifth assessment revised them upwards relative to the fourth, but a lot of glaciologists would like to see them revised upwards a lot more because of this retreat from Greenland and from the Antarctic. But perhaps the greatest immediate threat is the fact that as the sea ice retreats in summer, this opens up large areas of continental shelf, which then are able to warm up because of the insulation and the fact that the water is shallow. So we now see these big temperature anomalies in summer around the shelves of the Arctic. And the most shallow shelf of all is the East Siberian shelf, where a lot of field work has been done in the last few years, observing methane plumes being emitted, and this is thought to be due to the fact that offshore permafrost in that area is now thawing because of the warmer water temperatures in summer. This is releasing methane hydrates as methane gas, and this shows some results from Shakova and Semiletov, which is showing methane plumes rising and coming up to the surface and being emitted, because it's not true to say that methane, which has been observed being emitted from the Arctic, is not getting into the atmosphere. It doesn't get into the atmosphere when it's released from deep water because it dissolves on the way up. But when it's released at only 50 to 70 meters, it doesn't have time to dissolve and it comes out into the atmosphere. And this is a very big climatic threat. So this is what it looks like. And we did an analysis, some colleagues did an analysis of this at using the Pages model, which is the model used by the Stern Review, the UK government estimate of costs of climate change. And this is an integrated assessment model. And they came to the conclusion that if there's a large methane outbreak due to this phenomenon, then it could cause a large amount of warming in a short time. So the estimate there is this, not easy to see, but the centre line there show the blue is our present IPCC predictions of warming in the next 80 years, and the red is what would happen if there were a 50 gigaton methane outbreak, which is about a 0.6 of a degree increase, plus very, very high costs, because that model was actually an economic model, the Pages model, and it came to some very large figure like $60 trillion as the extra cost to the planet over a century of methane emissions due to retreat of sea ice. So retreat of sea ice may have economic opportunities for the world, but the costs are going to be very much greater because of the impact of the climate change, resulting climate change on the planet as a whole.
Thank you. Thank you very much. Thank you very much. Thank you, Peter. Close to home now, I'd like to introduce Ingibjörg Jónsdóttir. She is Associate Professor at the Faculty of Earth Sciences at the University of Iceland. Ingibjörg, please take the floor.
Good morning. I'd like to present the International Ice Charting Working Group, and it was funded in 1999 to promote cooperation between ice services mainly in the Northern Hemisphere, but it has recently extended its efforts to the Southern Hemisphere. And only a week ago there was a meeting in Chile, in Punta Arenas, and so the focus has been to that region as well. There are annual meetings and sub or smaller meetings as well, but the group, even if it's focusing on increasing navigational safety due to both sea ice and icebergs, there's a very deep understanding of the necessity to combine research and monitoring. So there are two standing committees, one on data, information and customer support, and another on applied science and research. Now, the focus is very much through remote sensing, because that's a technology that will allow you to have immediate or almost immediate overview over the conditions. And but studying sea ice in that way has some challenges, because obviously it's a dark and cloudy region at times, and also there's a very high demand on getting data immediately to the users. And so one of the solutions is obviously to use radar images, which are independent on cloud cover and light. But sea ice remote sensing is very much using all available imagery. So it's been very encouraging to hear all the plans in the future on new satellites being set up and great enhancement in that region. One other factor is that there's a very high demand on both sides of collaboration between end users and also data providers. And so these annual meetings are very have the same essence as Arctic Circle, where you have this forum of very different groups using different technologies and methods to try to increase safety. And one of the things that has been set up is so-called ICE logistic portal. So it's one key access to ICE services in different regions. So you can click on this map and get access to the newest information from each region. Now, I think I'll skip discussing the development on the sea ice recently. I think other people have covered that. But however, I'd like to stress that even if the trend in the north is very strongly towards much less sea ice, like Peter has just showed us, then every year there are regional differences. And also in the Antarctic, we've been seeing increased sea ice, which also causes challenges for navigation. And in the last week's meeting, they released a kind of a statement to the press and saying that accurate, timely analysis and forecasts of ice conditions are essential for safe and efficient navigation in polar waters. The members of the International Ice Charting Working Group are committed to improving their collective capabilities by sharing their information and expertise in the interest of marine safety. So basically, people are worried about increased shipping in the region and that people are maybe underestimating the threat that sea ice and iceberg still pose. And just last year, the International Ice Patrol counted more than 1,500 icebergs drifting into the Atlantic. And so obviously this is causing considerable threat, both to ships and also to different platforms. And just to put this in historical perspective, this was the 6th most severe iceberg season for over a century. Thank you.
Thank you very much, Ingibjörg. I'd like to introduce now David Hick, who is professor in the Department of Biological Sciences at the University of Alberta in Edmonton, Canada. Please take the floor.
Well, good morning. What I'd like to do in just a very few minutes is address this last part of the topic of this session, scientific cooperation, and just give you a few insights to, within the Arctic science community, how we see the opportunities for cooperation in the next few years. Certainly in the hallways, in the breakout groups, in the panel discussions over the last few days, this question of cooperation among scientists and across disciplines, cooperation between funding agencies, cooperation with other sectors and business has been a central theme. And it's something that has certainly occupied us within the Arctic science organizations for a little while. So I'll talk about these 3 acronyms here. First, the International Arctic Science Committee, which is a non-governmental organization which was created in 1990 by the 8 Arctic states and now has 22 member countries. And works very closely with all of the polar science organizations to promote and support multidisciplinary research and to improve our understanding of the changes taking place in the Arctic region in all respects and how that fits into the Earth system as a whole. And we work closely with other science organizations and, of course, with Arctic Council. Now, I just want to tell you about 2 initiatives that IASC and other partners are involved in right now. One of these is the International Conference on Arctic Research Planning, the 3rd ICARP, and the International Polar Partnership Initiative. And both of these are really efforts to try to improve our coordination of the science and its impact in the longer term. So let me just say something about ICARP, or this International Conference on Arctic Research Planning. Periodically, and it's turned out to be on a decadal period, IASC and partners have convened a forum for identifying key scientific questions, issues, and priorities. So the first was in 1995 in Copenhagen, in 2005, which resulted in this report Arctic Research, A Global Responsibility, and the science plans from ICARP to, I think, had quite an influence on many of the activities during the International Polar Year. And right now we're in the middle of the third ICARP, and I'll describe that now. So our approach is to try to better integrate Arctic research and develop a roadmap for the future. What are the priorities? How can we improve coordination? What does the science community really need to provide for policymakers and for people who live in and near the Arctic and for the broader global community, and to improve the relationships among those who produce the knowledge and those who require it? There are many partners involved in this effort. It's very much an effort of organizations that are already involved in many aspects of Arctic research, taking advantage of the meetings and the activities that they already support so that we can minimize the amount of additional travel and additional meetings. And so a forum like this, the Arctic Circle, is a great opportunity to continue those discussions. The program launched itself at Arctic Science Summit Week in Helsinki in April. There are many events almost weekly throughout the year, and the culminating conference will be during Arctic Science Summit Week in Toyama, Japan next year. And in fact, if you're interested in attending the Toyama conference, as a little commercial, the call for abstracts is open for another couple of weeks. And even here, over the yesterday evening and this evening, IASC, in collaboration with RANES, has two sessions where we're discussing science and technology of disappearing ice, and the outcomes from those sessions will feed directly into ICARP. So the outcomes will be the summaries of all of these various activities, a consensus statement on what those priorities are, and we hope this will be useful for many audiences, and from that a roadmap that we can use to plot how to be successful in improving how we can conduct our science in the coming decade. And this, we hope, will feed into the second initiative, the International Polar Partnership Initiative. So this wasn't the name that we started with. This was originally proposed as the International Polar Decade. But over the last few years, Qnrur and I have been sort of gently co-chairing a steering group of many organizations that have an interest in looking at how we can sustain our efforts in Arctic science and polar science more broadly in the longer term. This is really an outcome of the International Polar Year and trying to make sure that the legacies of IPY are not forgotten, the scientific legacies, the collaborative legacies, and the human legacies. And so we need a mechanism to do that. The idea of a polar decade, I think, scared a lot of people. The idea of 10 IPYs back to back was a terrifying prospect for those of us that survived IPY. It was such a huge effort. We realized that putting resources into this type of science all at once, and to only do that every 2 or 3 or 4 decades, probably wasn't the best approach going forward. Every year is a polar year. How can we sustain that effort in a useful way over the longer term? So this has evolved then into the International Polar Partnership, and we have many partners. We're in the middle of trying to discuss and receive input from other organizations in how to proceed. And I'll just briefly describe the concept. The aims are to upgrade and sustain our observing system so that we can have better prediction and assessments in the future, to strengthen the platforms for collecting data, to continue to build long-term capacity in the Arctic, in the global community, and certainly to encourage early career scientists to participate and see a career over there, or to see a long-term career in this sort of work. And of course, to develop these synergies between different sectors, not just within the science community. So our timetable right now is really by the end of this year to have completed a broader consultation with organizations that have an interest in supporting and sustaining the concept of IPPI, and to look for endorsement from those organizations and to perhaps launch some initial activities by next year. So your comments and input are welcome, and certainly venues like this for introducing the idea of a sustained effort over the long term for Arctic research, and how to make that as useful as possible for a broad and diverse group of stakeholders is the effort that we think is necessary and that we're engaged in right now. Thank you.
Thank you very much, David. Last speaker in this session is Sang-Woo Han, Director of the Korean Polar Research Institute. Han, please.
Thank you. I'm glad to be here with you today. This presentation deals with the Korean Arctic research activities. This presentation consists of 4 parts like this. It is not too much to say that the history of Korean Arctic research is that of KOPRI, Korea Polar Research Institute. In 1987, Polar Research Lab opened in Kordi. 1988, Antarctic King Sejong Station opened. 2002, Arctic Dasan Station opened. 2004, KOPRI opened attached to Kordi. 2009, Icebreaker Around launched. 2014, Antarctic Jangbogo Station opened. KOPRI has 2 roles. One is as a research institute. Another is as a national operator. KOPRI has 4 research infrastructures: Arctic Dasan Station, Antarctic Sejong Station, and Jangbogo Station, and Icebreaker Around. Representative Korean Arctic researches are these 4. Circum-Arctic Environmental Change Monitoring Research, and Arctic Sea Research, Arctic Climate Change Research, and Reconstructing Past Climate and Environment Changes. Circum-Arctic Environmental Change Monitors. Since 2011, we are setting observing sites around Arctic. We have We have operated the atmospheric observation council in Alaska. Permafrost melting depths were measured. We have tried to set up a ubiquitous sensor network. We also participated in the SIOS program. Arctic Sea Research is monitoring ongoing environmental changes in Arctic region by using Icebreaker Around. Icebreaker Around has these characteristics. Cape Port program deals with the Arctic Ocean survey, mainly focused in Chukchi Sea, and monitoring sea ice variation, Arctic ecosystem changes, Arctic Ocean acidification. In 2014, Arctic Ocean field activities were carried out from July 17th to October 5th. The study area is this year is Chukchi and East Siberia and Beaufort Seas. Arctic climate change research is focusing interrelations between Arctic and middle latitude region. September in this year, the paper presented in Nature Communications, and it was reported by many press. we have researched reconstructing past climate environment changes. And Korea has joined the multinational NEAM project during 2007 to 2012. We have outreach program for high school students to visit Dasan Station in Svalbard. They experienced the trekking and coring and observing and simple laboratory works. Qnrur has a broad international cooperation network. Qnrur participating in the various Arctic-related science organizations. Korea and Norway, Qnrur MPI Cooperative Research Center was opened in Prime Center in Tromsø, Norway in April in this year. Mr. Jan Gunnar is co-signing like this. And Qnrur scientists have conducting field research in Resolute and Cambridge basins 2009. Qnrur has co-work research activities in Jakenburg, Greenland. And Qnrur has co-work Arctic science cruise since 2000 with Russia. And we have cooperation networks with Japan, Sweden, USA, and Finland and Iceland. Let me close this presentation with the subject, why Arctic research for Korea? The answer is to join international effort to address global issues like climate changes. And Korea is subject to Arctic influence, location of the Korean Peninsula, weather, and economy, and to contribute to environmental protection and sustainable development in the Arctic. Thank you so much.
Thank you very much, Han. And thank you all very much for your excellent presentations. It's been fascinating to follow the breadth of topics that you have covered here in this session, and indeed the diverse backgrounds that you all have in anthropology, law, geosciences, mathematics, physics. And this again, of course, emphasizes the need for interdisciplinarity in the search for new knowledge in Arctic issues. Ladies and gentlemen, we have time for a couple of questions, if you have, from the audience. I'd like to ask you to go to the microphone and introduce yourselves.
Hello, yes. My name's Ed Hawkins. I'm a climate scientist from the University of Reading and an IPCC contributing author. So I've got a question for Peter. So, I mean, the IPCC has today published its synthesis report, which represents the consensus view of thousands of climate scientists. And your views on the sea ice and the imminent methane pulse disagree with that consensus view, as I'm sure you recognise. And you also showed this, the biomass model volume data from the Arctic and fit this curve projection to it. Is that projection published in the peer-reviewed literature, and does it have any basis in physics?
Please. Should be on. It should be on.
Okay, well, where should I start? First of all, the rapid retreat of the sea ice is actually based on data. As you know, it's based on the combination of the thickness measurements done from submarines and the extent measurements done from satellites. So that is based on data, not a model, and that is predicting rapid retreat leading to loss of summer sea ice earlier than the IPCC predicts. And the IPCC has steadily become somewhat more radical in the dates at which it thinks the Arctic sea ice is going to disappear. But it's an ongoing process, and those who actually go out into the Arctic and measure thickness and extent find that the process of retreat in summer is such that the disappearance will happen earlier than the IPCC predicts. And so I think that's my main answer.
Does your projection have any basis in physics, your curve-fitting exercise?
Well, of course it does.
The Royal Society meeting in July, you said it didn't have any basis in physics, so...
Well, at the Royal Society meeting in July, you were twittering behind my back while I was talking, so I didn't really like that very much.
And so you issued legal threats to other climate scientists afterwards?
I wasn't issuing any threats to anybody. I was protesting to the Royal Society about the use of Twitter in Royal Society meetings, which I thought was improper and not good ethics.
People can read your letters.
Thank you very much. Thank you very much. We'll move on to the next question over here, please.
Hi. This is a question for Madame Figueres. My name is Lee Hyo, and I'm a Canadian conducting Arctic research at Dartmouth College, which, by the way, I appreciated the shout out to young researchers because that was the best experience I had is conducting research in Greenland. I'm involved with Sustain Us in the Youngo Youth Constituency at the UNFCCC. And I just wanted to thank you for bringing up future generations in your talk. As you know, we aren't given a seat at the table at these negotiations, and I appreciate your efforts to try to include youth. I'm wondering if you think that youth can use the Arctic as a way to get more engaged in the negotiations in a more direct way rather than tangential, and if you think that is the case, can you define what that engagement would look like?
Topic very close to my heart, and one that we have actually been opening up over the past 4 to 5 years, which is the participation of non-governmental stakeholders in the negotiations. I actually think that governments have finally come to the conclusion that they will not solve climate change on their own, that they actually need. It's not just a government issue, it is an everyone issue, and that they need to really be much more welcoming of solutions that can come from other stakeholders. So the good news for you is the discussion is on the topic, on the table, and I do believe that governments who are the ones who decide the rules in the Climate Change Convention are looking at different options as to how they're going to open that up. Specifically, if you're following our discussions, it's through the work of Workstream 2. So specifically, my answer to you is through, yes, through the Arctic, but also in the convention through Workstream 2, and you have a lot of supporters out there.
Thank you. Thank you very much. Over here again.
Thank you. I'm Pinkos Javits from Sustainability Tank, and I'm sporting this tag that says I was there on the streets of New York on September 21. Now, my question to Dr. Figueres is, having watched the UN for years on the dealing with climate change and the problem of not being able to get consensus between 193 nations, even now with the addition of the civil society. Now, would it be acceptable to get simply a series of statements by individual nations, what they are ready to commit themselves for, and use this as an umbrella and that will create the Declaration of Paris?
Those statements are coming forward, and they're coming forward not just as alliances of willing nations, but also as alliances of corporations, of banking institutions, of asset owners, asset managers, and they're all very helpful. Are they sufficient? No. They're definitely a necessary condition, but it is not sufficient, because the United Nations stands on the very, very clear principle that no country can be left behind, that no community can be left behind. And I wouldn't want to belong to the one country or the two or the three who wouldn't be in those alliances. So it is very important to have all of those different alliances, and the more surprising alliances, the better. But in addition to that, we do need the consensus and the agreement and the collaboration of 194 countries.
Is it possible to use bilaterals in order to bring in those countries that by themselves cannot do it?
Yes, and many bilaterals are coming forward. Perhaps the most important, which will not be any surprise to you, is the bilateral cooperation that has been developing between the United States and China, the two highest emitters. And it's a very, very helpful process that we have seen over the past few years, where these two countries are actually helping each other not only address their domestic challenges, but actually cooperate with each other in order to be able to do more at the international level.
Thank you very much. Next question, please.
Yeah, good morning. My name is Michael Karcher. I'm working at the Alfred Wegener Institute for Polar and Marine Research as an ocean and sea ice climate researcher. And I'm also assistant coordinator of the European funded Access project. Thank you very much for these very interesting and relevant presentations. We have heard a lot about ongoing activities in terms of research cooperation, science cooperation. Sorry, but there's one field which is missing, and I would very much like to support the pledge of Jane Francis for an international infrastructure for truly internationally funded research. We are faced with a situation that if there's a group of scientists from different parts of countries which have a research idea for the Arctic, they have no one place to go to ask for research funding like we would have inside the European Union. But this is very limited, of course, as we all know. So I wonder whether it would be possible to raise this as one important issue on the IPPI or ICARP3 initiatives, to get together with the group of national funding agencies to be able to form something like that for the Arctic research.
So that is part of the conversation. There are groups like FARO, the Forum of Arctic Research Operators, that are looking at how to better coordinate existing infrastructure. And in response to your question about new infrastructures, I think this is an important thing for the community to identify, and then we can work with governments and other funders to see how we could resource it.
Yeah, thank you, but I'm not only referring to infrastructure, I'm referring to research, and these are two separate, but both very important parts.
Yes, please.
But thank you.
Please do. Fran, would you like to add something?
I'd just like to add one observation, and that is that the Arctic Council has been discussing a new possible agreement on international research cooperation. And that the task force that has been working on the language is getting closer to a place where the nations might be able to agree to this new level of international cooperation for Arctic science under the Arctic Council. Now, the current version does not address funding, but I think it takes to another level the extent to which the Arctic Council wants to move forward in different methodologies for bridging some of these very important challenges and gaps that exist in our current system. So I would say stay tuned to that process and interact through the observers, permanent participants, and the member nations to talk about how to take it to the next level, because I do think it illustrates an opportunity for us to think creatively about different ways of doing business.
Thank you. Jan, did you want to?
Yeah, very briefly to your question. I think you are pointing at a very central part of what is kind of lacking. I don't think the managers of national programs and the ones sitting on the infrastructure is the main problem here, the key problem. The key problem is sitting with the funding agencies that need to follow what I mentioned, more the IPY model of coordinated multilateral funding mechanisms. And Fran Ulmer is pointing in one process, pointing in that direction.
Thank you. Jane?
Just very quickly, the UK and the US, NSF and NERC, the two funding agencies in those two countries, are beginning to have some ideas along this way. They have a new program to share projects. So you have one project with two national groups, one project goes out for one review, so that gets rid of the double jeopardy system. I think we need to go a long, long way with a lot more countries involved, but it is there in the conscience of some of the funders.
Thank you. I'm afraid we'll have to wrap up now, and I'd like to say thank you again to all the speakers, and thank you to all of you for your participation. Thank you.